Hello, algebra students. This is lesson 5-3, step functions. Our learning target today is to use step functions to represent real-world situations. Step functions. And our vocabulary is floor function, función de piso, ceiling function, función de techo, step function, función de paso. And for our next fill in the blank, we have the floor and ceiling functions. Give us the nearest integer up or down. For example, what is the floor and ceiling of 2.31? And there's a picture here. 2 would be the floor because that's going down. And ceiling would be 3 because that would be rounding up. So it's actually not like rounding because, rounding, if it's 0.5 or greater, you round up. But this is just saying, what are the two numbers that 2.31 is between? It's between 2 and 3, and so the floor is 2 and the ceiling is 3. Also important are the symbols. The symbols for the floor and ceiling are like the square brackets with the top or bottom part missing. So on the floor here, we have the bottom part. Makes sense, right? And for the ceiling, we have the top bracket. And you can write it as floor parentheses x or ceiling parentheses x, or you can write it with the brackets. So let's try this. Evaluate each function for the given value. All right, so for part A, the first thing we want to find out is, do we have a floor or a ceiling? And so it looks like the little brackets are on top. You may need to make that a little darker in your notes. And that would mean that we have a ceiling because the brackets are up here at the top. And the ceiling, so if we have 2.65, that's between 2 and 3. So the ceiling would be the bigger number, so it would be 3. The ceiling of x equals 3. F of x equals the floor of x, and x equals 2.19. So the floor function for x, if 2.19 is between 2 and 3, the floor would be the smaller number, 2. And as we move on on this page, there is a typo. I don't think I made this typo. I think I just copied and pasted it. But we have a ceiling function, and a step function. Let's change that second ceiling, and we're going to rewrite floor in there because the brackets are below. So this brackets make them a little darker, and the brackets above are for the ceiling. All right. We want to draw a line from each function to the graph it describes. So the ceiling function for x means that we're going to include the top value. So this here would be the top value because the filled in circle is right here. And for example, let's pick this very first one that's at 1. It goes from 0 to 1, so 1 is going to be the ceiling. And the floor function will be the other one, and we can see that if we pick that same point at 1, from 1 to 2, that shows the floor function because between 1 and 2, 1 would be the smaller value. All right, and the next thing that we have is just a regular step function, and that's going to be the center graph here. All right, so we have the floor function, we have the ceiling function, and we have a step function. Let's turn our page. This is example 2. Use a step function to represent a real-world situation. The postage for a first-class letter weighing 1 ounce or less is 0.47 or 47 cents. Each additional ounce is 21 cents. The maximum weight of a first-class letter is 3.5 ounces. Write a function to represent the situation. So let's take into account some of the information that they give us. If it's 1 ounce or less, it's 47 cents. But after that, they charge you 21 cents per ounce. And how could we write that function? So when we're asked to write a function, we use f of x, and we want to think about how we would write an equation to demonstrate this situation or to represent the situation. So we have f of x. That's what we use for functions. And it says that 1 ounce or less is 47 cents. So it just equals 47 cents if the package or the letter that we're sending is less than or equal to 1 ounce. And that's how we write that inequality. So if x is less than or equal to 1, we don't need to do any math. It's just 47 cents. But then there's the part that says each additional ounce is 21 cents. We also need to think about that the first class letter maximum weight is 3.5 ounces. That's the maximum weight that we can send. That being said, our x, which is the package that we're sending, the weight of the package, has to be less than or equal to 3.5 ounces, or greater than 1. That would be our interval for when we're paying 21 cents more per ounce. All right, so we have our f of x. Again, or maybe this would be, no, it's still f of x, not g of x. So f of x is going to equal the 47 cents. We still have to pay that for the first ounce, but every ounce after the first ounce is 21 cents. So we're going to have plus 21 cents per x that comes after the first x. So we have to have a parentheses x minus 1 to show that. Oh, my handwriting kind of got in the way, so I'm just going to move this over. It's going to be the same thing, it's just that my handwriting went into itself. So if x is greater than 1 or less than or equal to 3.5 ounces, that just means between 1 and 3.5 ounces, or greater than 1. All right, that is how you write a step function to represent this situation. So we had our 1 ounce or less function, and we had our each additional ounce after that. All right, number 2, A. Kylie is fixing a spaghetti dinner for the volleyball team. She uses the graph to determine how many packages of pasta she needs to buy. Write a function for the graph. So first we want to look at the story that they're giving us. If Kylie needs to buy between 3 and 6 ounces of pasta, how many packages will she need? Right? She will need blank packages. So let's look here. This is a step function, and it looks like a ceiling because we're going to end on the larger number. So between 3 and 6, then she would need how many packages? And the packages are on the y. So she needs 2 packages. Okay, between 3 and 6, she needs 2 packages of pasta. So we're going to fill that in with a 2. If she needs between 12 and 15 ounces, let's find that on our graph right here, she's going to need how many packages? Yeah, 5. So how could we write that as a function, a step function? Mostly they'll probably ask you, like on a standardized test, is just to interpret it like we just did. But if we wanted to write a function, let's see. For 1 package, she needs 3 ounces. For 2 packages, or for 3 ounces, she needs 1. For 6 ounces, she needs 2. So I would say like we're multiplying. Let's find our slope here. Going up 1 over 3, up 1 over 3, up 1 over 3 to get these dots. So our slope is 1/3. So let's see if this works. 1/3 x. If you needed 12, that would only be 4, right? So that doesn't really work. No, actually it does work. But it would be a ceiling function of this. So f of x equals 1/3, but we want to use our ceiling function. So we would say the ceiling of x equals this. For this problem, we will be interpreting a ceiling step function graph. And it says, Jamal and his brother plan to rent a karaoke machine for a class event. The graph shows the rental cost. How much should they expect to spend if they rent the karaoke machine from 8 a.m. until 7:30 p.m.? And it looks like we can either use the graph or we can use the diagram that they gave us. But before we figure anything out, it's talking about hours, and we need to know how many hours it is from 8 a.m. to 7:30 p.m. I know that if it was from 8 a.m. to 8 p.m., that would be 12 hours. But since it's only until 7:30, it's going to be half an hour less than that. So it's going to be 11.5 hours. But I don't think it matters because it's a step function, and so we're not even going to worry about decimals. We're just going to deal with hours. So we're probably going to be dealing with 12 hours anyway instead of the 11.5 hours. All right. And as we look at the step function, if you rented it for between 0 or greater than 0 up to 1 hour, you pay $30. And then if you rent it from more than an hour up to 2 hours, it's 40, and then 50, 60, 70, 80, that we're going up. So the little diagram picture says it's $30 for the first hour. So we have 30, and then we have $10 per hour after. So the first hour is $30. After that, it's $10 per hour after. So I think we'll write this as 2 functions. Maybe I should have done that on the last problem. So it's $30 for the first hour. So f of x equals 30 when x is less than or equal to 1, but greater than 0. Then f of x is equal to 10, and I think we're going to write it as x minus 1 because we're not going to include the first hour, and then we're going to add 30 to that. And that is if x is greater than 1, but less than or equal to, I don't know, I guess it's infinite. So we can just write it as x greater than 1. Now let's figure this out. If we're going to rent it for 12 hours, because it's basically 11 and a half, we want to use a ceiling function, then we would have 10 times the 12 hours minus 1 plus 30. Because the first hour was 30, so $10 times the 11 hours plus 30, and that is going to equal $110, $140. That's how much you can expect to pay to rent the karaoke machine for 11 and a half hours. $140. Might as well buy one at that point, right? Kind of expensive. Would you pay that much if you were going to rent it for a class event? All right, let's put our notes away and start our assignment for today for 5-4. Or I'm sorry, 5-3 step function.